Here's a formula to make the variation of parameters easy. Variation of parameters is one way to solve a non-homogeneous differential equation like this. So on the right side you have some function that's not zero. Now if we call the two functions y1 and y2 the two solutions to this homogeneous differential equation, then the entire variation of parameters method boils down to the following formula. So if you worked out the entire variation of parameters formula, at the end of the day, this is what you're getting. Where this w here is really the Wronskian of the two functions y1 and y2. Okay, let's see. Let me copy this to the next slide. And I want to show you a demonstration of this formula. Okay. All right. So here's a differential equation, y double prime minus y equals to x. It's a very simple equation. In fact, if you just took a minute to think about this using the method of undetermined coefficients, you can even just mentally solve this and immediately write its solution. But I just wanted to show you how this formula is applied, so let's just proceed. First, you need the y1 and y2, which are homogeneous differential equation solutions. So think about y double prime minus y equal to 0, which is solved by using the characteristic equation, right? Y double prime, that's r squared, negative 1, here, right here. And if you solve this, you get r equals to 1 and negative 1. Therefore, y equals to e to the x and y equals to e to the negative x are the two solutions of the homogeneous differential equation. Now in the formula, we need to know what the Wronskian is. So we have to compute the Wronskian first. What's the Wronskian? You write down the two solutions, and then you differentiate once, and you get this matrix, whose determinant is computed by AD minus BC. Right? So you have to multiply diagonally and then multiply anti-diagonally and to subtract. And this is the result. Now remember that e to the negative x is 1 over e to the x. So if you multiply these two, they just cancel each other to give you 1. And you just get negative 2 as the Wronskian. Usually the Wronskian is not this simple, but I chose this question so that Wronskian will come out as a really simple thing. Let's compute the particular using this formula here. It's supposed to be y1 times y2 times f of x. What's the fx here? Fx right here is the function on the right side. That's what we call the fx in the formula. So we take this and put it right here. Okay. And then it's y2 and y1. y1 and y2 change their roles and you integrate. Now then we can proceed to integrate by pulling these negative 2 down here. Because these are constant, I can pull it outside the integral. If it was not a constant, then you'll have to integrate the entire thing. But thankfully for us, it's a constant. So let's pull it out, which is 1/2 here. That's negative 1/2 here. And then what's remaining, these should be integrated by calculating with integration by parts or tabular integration. Either way is fine. And if you do it, since this is very elementary, I'll just write down the solution. These are the solution. And there are two options here. Since you're just looking for one particular solution, you don't have to put plus c. But if you decide to put plus c, you'll find out that it produces, with the plus c1 and plus c2 in that case, if you were to put the c's in here, you have to put c1 and c2. And it will generate not just a single solution, but it will write down a solution with two free parameters, and therefore you end up with a general solution. So that's what some people prefer. I like to just not write c1 and c2 because it's easy to forget that you have to write c1 here and c2 there. Okay, so if you just apply the integration by parts, you get these. And then if you simplify, at the end of the day, you get negative x. Now let's see if negative x really is a solution. Negative x second derivative is 0. Negative of negative x is positive x, and in fact it is equal to x. So we do know by quickly checking that negative x is a particular solution. Now if you have a particular solution, how do you write down the general solution? Well, you write down the general solution by making it as yc plus yp, and therefore this is the final answer.